In 1969, a human being stepped onto another world for the very first time, and in that moment, everything changed. It wasn't just a technological achievement, it was a shift in perspective. For the first time in history, humanity was no longer confined to Earth. But what most people don't realize is that since that day, no human has ever gone farther. We've built space stations orbiting the planet, sent robotic explorers across Mars, and launched probes beyond the edges of our solar system, yet when it comes to human beings, we've stayed close to home, circling the Earth again and again, never truly venturing back into deep space. For more than 50 years, that vast expanse beyond our orbit has remained untouched by us, not because it's impossible to return, but because going back is far more complex than getting there the first time. That is about to change. For the first time in a generation, astronauts are preparing to leave Earth's orbit and travel into deep space once again, not for a brief visit, but to begin something far more ambitious. This mission is called Artemis II. At first glance, it might not seem as dramatic as the Apollo landings. There will be no footprints pressed into lunar dust, no flag planted on the surface, no historic first step broadcast across the world. But that's exactly why it matters. Artemis II is not about spectacle, it's about proof. It's about demonstrating that humans can safely travel beyond Earth's protective boundary and survive in an environment that is far more hostile than anything we've experienced in modern spaceflight. Low Earth orbit, where astronauts live and work today, is still shielded by our planet's magnetic field, which protects them from the worst radiation space has to offer. But once you leave that invisible barrier, everything changes. Radiation levels rise, communication becomes delayed, and the margin for error shrinks dramatically. If something goes wrong that far from Earth, there is no immediate rescue, no quick return, only systems, training, and decisions standing between survival and disaster. Every component of the spacecraft must function perfectly, from life support and navigation to power systems and thermal protection. Even a small failure can quickly escalate into something far more serious. That is why Artemis II exists, not as a symbolic journey, but as a full-scale test of what it actually takes to send humans into deep space again. Inside the spacecraft will be 4 astronauts, each carrying years of training and experience, but also stepping into a mission filled with uncertainty. They are not just passengers, they are part of the system itself, testing how the spacecraft performs with human beings on board. Together, they will travel farther from Earth than any human has in decades, possibly even surpassing the record set during the Apollo era depending on their trajectory. And when they look back, Earth will no longer appear as the vast world we know, it will shrink into a small, distant sphere, suspended in darkness, fragile and alone. Distance in space is difficult to comprehend because it operates on a scale far beyond everyday experience. The Moon sits nearly 400,000 kilometers away from Earth, a distance so great that even light takes over a second to travel between the two. During Artemis II, the crew will journey out to that distance and beyond, moving farther than satellites, farther than space stations, and farther than any point where help can easily reach them. At that range, they are no longer just astronauts orbiting Earth, they are deep space travelers, truly separated from their home planet in a way very few humans have ever experienced. Unlike the Apollo missions, which were designed for speed and efficiency with a clear objective to land and return, Artemis represents a different philosophy. It is slower, more deliberate, and focused on building a long-term presence beyond Earth rather than short-term exploration. The spacecraft they will travel in, known as Orion, reflects that shift. It is larger, more advanced, and built with the idea that future missions will last longer and go farther. It is not just a vehicle for a single journey, but a foundation for what comes next. Because Artemis II is not the final goal. It is the step before the next giant leap. Before humans return to the surface of the Moon, before permanent bases are constructed, and before missions to Mars become reality, this mission must prove that everything works. It must show that humans can once again leave Earth, travel into deep space, and come back safely. And when the countdown reaches 0 and the engines ignite, for astronauts will place their trust in a machine, in their training, and in each other, knowing that once they leave the ground, there is no turning back. Launch day begins long before the rocket ever ignites. Hours before sunrise, the astronauts wake up knowing that every step from this moment forward has been rehearsed countless times, yet nothing can truly replicate the reality of what's about to happen. As they suit up, surrounded by engineers and mission specialists, the atmosphere is calm but focused. There's no dramatic rush, no chaos, just a quiet understanding of the scale of what lies ahead. Outside, the rocket stands on the launch pad, towering into the sky, illuminated against the darkness like a structure that doesn't belong on Earth. This is the Space Launch System, the most powerful rocket ever built for human spaceflight, designed to do what hasn't been done in over half a century: send people beyond low Earth orbit and into deep space. As the countdown progresses, the astronauts are transported to the launch pad and begin the slow process of entering the Orion spacecraft. One by one, they climb inside, strapping themselves into their seats at the very top of the rocket. From this point on, their world becomes incredibly small, a confined capsule filled with displays, switches, and the steady hum of onboard systems coming to life. They won't see the outside world during launch, only the data in front of them and the voices of mission control guiding them through each step. Meanwhile, beneath them, hundreds of thousands of kilograms of propellant sit waiting, chilled to extreme temperatures, ready to release an immense amount of energy in just a few minutes. At T-0, the sequence begins. First, the core stage engines ignite, four powerful hydrogen-fueled engines roaring to life beneath the rocket. For a brief moment, the vehicle holds in place as these engines throttle up, stabilizing and preparing for what comes next. Then, the solid rocket boosters ignite. In an instant, the entire system transitions from controlled restraint to overwhelming force. The rocket surges upward, breaking free from the launch pad with a brightness so intense it can turn night into day. Inside the capsule, the astronauts are pressed back into their seats as acceleration builds rapidly, the vibration and sound unlike anything experienced in conventional flight. Within the first 2 minutes, the rocket pushes through the densest part of Earth's atmosphere, climbing higher and faster with every second. The solid boosters, responsible for the majority of the thrust, burn through their fuel quickly but powerfully. When they finally separate, they fall away from the rocket in a dramatic arc, leaving behind trails of glowing debris as they descend back toward Earth. The sudden change is noticeable inside the capsule as well, a slight shift in force as the vehicle transitions to relying on its core engines alone. By this point, the astronauts are already tens of kilometers above the surface, moving at speeds that make any return to the ground impossible without completing the mission. As the ascent continues, another critical system is no longer needed. The launch abort system, the pointed structure mounted above the capsule, separates and falls away. Its job was to pull the crew to safety in the event of a catastrophic failure during the earliest phase of launch, but now, high above the atmosphere, that risk has passed. For the first time, the astronauts are able to look out through their windows and see the curvature of the Earth beneath them, a view that very few people have ever witnessed in person. Roughly 8.5 minutes after liftoff, the core stage engines shut down. In that moment, the intense force of acceleration suddenly disappears, replaced by the sensation of weightlessness. The massive orange fuel tank detaches and begins its own descent back toward Earth, while the upper stage engine ignites to carry the spacecraft the rest of the way into orbit. This final push places Orion into a high, elliptical orbit around the planet, far above the altitude of the International Space Station. After about 20 minutes, the upper stage separates, leaving the crew alone in space, attached only to their spacecraft and the vast emptiness beyond. But the mission is far from truly underway. Over the next several days, the astronauts will remain in this elongated orbit, moving between points relatively close to Earth and distances far beyond anything reached in modern human spaceflight. This phase is not about exploration, but verification. Every system on board must be tested in real conditions, with real people depending on them. Life support systems are monitored continuously to ensure that oxygen levels, temperature, and pressure remain stable. Navigation and propulsion systems are carefully checked, including precise control of the spacecraft's orientation and movement. One of the most important tests involves manually controlling the spacecraft. At a certain point in the mission, the crew will rotate Orion and guide it toward a target left behind in orbit, the upper stage of the rocket that launched them. Using visual markers and onboard instruments, they will simulate a docking maneuver, carefully aligning and approaching as if connecting to another spacecraft. They won't actually dock, but the exercise is critical. Future missions will require Orion to connect with lunar landers in orbit around the Moon, and this test ensures that astronauts can perform those operations with precision. Throughout this phase, the crew remains aware that they are still close enough to Earth to return if necessary. If any major issue arises, the spacecraft can separate from its service module and begin the journey home. But assuming everything performs as expected, the mission will move into its next and most important phase. At the highest point in their orbit, when they are farthest from Earth, the astronauts will ignite the engine of the service module for a maneuver known as translunar injection. This burn will push the spacecraft beyond Earth's gravitational hold and set it on a path toward the Moon. Once that burn is complete, there is no simple way back. The spacecraft will enter a free return trajectory, a carefully calculated path that uses the Moon's gravity to loop around and send the crew back toward Earth. It is an elegant solution, one that provides a built-in safety margin, but it also marks a turning point in the mission. From that moment on, the astronauts are no longer orbiting Earth. They are leaving it behind, crossing into deep space for the first time in generations, committed to a journey that will carry them farther from home than most humans could ever imagine. Once the translunar injection burn is complete, there is a moment where everything changes, though nothing dramatic seems to happen at first. There is no sudden jolt, no visible boundary being crossed, just a quiet realization that Earth's gravity is no longer in control. The spacecraft continues forward, coasting through space on a path defined by physics alone. Inside the capsule, life settles into a rhythm, but it's a rhythm unlike anything on Earth. There is no up or down, no natural sense of direction, only the gentle drifting of objects and the constant awareness that every movement must be deliberate. Outside the windows, the view begins to transform. Earth slowly shrinks behind them, growing smaller with each passing hour, while the Moon, still distant, gradually becomes more defined. As the crew moves deeper into space, they enter an environment that humans have not experienced firsthand in decades. Beyond Earth's protective magnetic field, radiation becomes a constant presence. It's invisible, impossible to feel, but always there, passing through the spacecraft and everything inside it. For short missions, the exposure is manageable, but it is still one of the greatest unknowns when it comes to long-duration space travel. Artemis II provides a rare opportunity to gather new data, using modern sensors and wearable technology to monitor how the human body responds in real time. The astronauts themselves become part of the experiment, tracking everything from heart rate and sleep patterns to subtle biological changes that could shape the future of deep space exploration. Daily life inside Orion is both simple and complex. Every task, no matter how small, requires planning. Eating, for example, is no longer automatic. Meals come in sealed packets, dehydrated and carefully prepared before launch. Water is injected into the packaging to rehydrate the food, and everything must be consumed carefully to prevent crumbs or droplets from floating away into the cabin. Even drinking requires special containers designed for microgravity. Sleeping is another adjustment. Without gravity, there is no need for a bed in the traditional sense. Each astronaut secures themselves in a sleeping bag attached to the interior of the capsule, floating in place as they rest. There is no sensation of lying down, only the absence of weight. Exercise becomes essential, even on a mission of this length. In microgravity, muscles begin to weaken and bone density starts to decrease surprisingly quickly. To counter this, the crew uses compact exercise equipment, maintaining strength and circulation in an environment that constantly works against the human body. These routines are not optional, they are critical for ensuring that the astronauts remain physically capable of performing their duties, especially during high-stress phases like re-entry. But beyond the technical routines and scientific measurements, there is something else that defines this phase of the mission: perspective. With every passing hour, Earth becomes less dominant in the sky. What was once a massive, detailed world transforms into a small, bright sphere suspended in darkness. Continents blur together, weather systems swirl across its surface, and the thin layer of atmosphere becomes more apparent than ever. It is a view that very few humans have experienced, and it has a profound psychological effect. From this distance, borders disappear, conflicts become invisible, and the planet as a whole appears fragile, isolated, and finite. Communication with Earth continues, but it is no longer instantaneous. As the distance increases, even signals traveling at the speed of light take noticeable time to make the journey. Conversations develop a slight delay, a subtle reminder of just how far away the crew has traveled. Mission control is still there, still guiding and monitoring, but the astronauts are more independent now than any crew in recent history. Decisions on board carry more weight, and self-reliance becomes increasingly important. Midway through the journey, the crew prepares for one of the mission's critical safety procedures, the radiation shelter drill. While the spacecraft is designed to provide a baseline level of protection, there is always the possibility of a solar event, an eruption from the sun that can send high-energy particles racing through space. If such an event were to occur, the astronauts would need to act quickly. They would move into a designated area within the capsule, surrounded by supplies and materials that provide additional shielding. It's not a perfect solution, but it significantly reduces exposure during short-term spikes in radiation. Practicing this procedure ensures that if the unlikely happens, the crew will be ready. As the days pass, the moon begins to dominate the forward view. What started as a distant object now grows into a massive presence, its surface features becoming sharper and more detailed. Craters, ridges, and vast plains come into view, revealing a landscape shaped by billions of years of impacts and geological history. Unlike Earth, there is no atmosphere to soften its appearance, no clouds or oceans to obscure its surface. It is stark, silent, and unchanging. By the time Artemis II approaches the moon, the crew will have spent nearly a week in space, traveling hundreds of thousands of kilometers from home. They are no longer just observers of space, they are participants in it, moving through an environment that is as unforgiving as it is awe-inspiring. And as they prepare for their closest approach, they are about to witness something that has only been seen by a handful of people in all of human history: the far side of the moon, a region forever hidden from Earth, waiting just beyond the horizon. As the spacecraft approaches the moon, the sense of scale begins to shift once again. What once appeared as a distant object now fills the windows, stretching far beyond the edges of their view. The surface is sharper, more detailed than any image can truly capture, covered in impact craters, jagged ridges, and vast plains frozen in time. There is no atmosphere to blur the horizon, no weather to reshape the landscape, only the raw history of the solar system preserved in silence. As Orion moves closer, the crew prepares for the moment they will pass behind the moon, crossing into a region that has remained hidden from Earth for all of human history. When they reach the far side, something unusual happens. Communication with Earth is lost. Not because of a malfunction, but because the moon itself blocks the signal. For the first time since launch, the astronauts are completely on their own. No voices from mission control, no real-time guidance, just the quiet hum of the spacecraft and the awareness that they are farther from Earth than any human presence at that moment. It's a brief period, measured in minutes, but it carries a psychological weight that is difficult to describe. Every system continues to operate, every procedure continues as planned, but there is a subtle shift in perspective. Out here, there is no immediate connection to home. And then, just as quickly as they arrived, the spacecraft begins to move away. The moon's gravity takes hold, bending their path and redirecting them back toward Earth. This is the turning point of the mission, the moment where the outward journey ends and the return begins. The free return trajectory does exactly what it was designed to do, using the natural motion of celestial bodies to guide the spacecraft without the need for large amounts of additional fuel. It is a precise balance of speed, distance, and timing, one that has been calculated down to the smallest detail. As Orion leaves the moon behind, Earth slowly reappears, growing larger with each passing day. What was once a distant point of light becomes a recognizable world again, its colors and features returning as the distance closes. The crew resumes their routine, continuing experiments, monitoring systems, and preparing for the final phase of the mission. But there is a noticeable shift in mindset. The most distant part of the journey is behind them, and now their focus turns toward coming home. Re-entry is the most dangerous phase of the entire mission, not because of distance, but because of speed. As the spacecraft falls back toward Earth, it accelerates to incredible velocities, reaching speeds far greater than those experienced by vehicles returning from low Earth orbit. At these speeds, even the thin upper layers of the atmosphere become a significant obstacle. The friction generated as Orion collides with air particles produces extreme heat, building to temperatures that can exceed thousands of degrees Celsius. The heat shield, a critical component of the spacecraft, must withstand these conditions and protect the crew inside. In preparation, the service module separates from the capsule, having completed its role in propulsion and support. The crew module, now on its own, reorients itself so that the heat shield faces forward, taking the full force of re-entry. As they begin to descend, the outside of the spacecraft becomes enveloped in plasma, a glowing layer of superheated gas that forms as the air around them ionizes. For a period of time, this plasma sheath can disrupt communications, creating another brief window where the crew is once again out of contact with Earth. Inside the capsule, the astronauts experience intense forces as the vehicle decelerates rapidly. After days of weightlessness, the sudden return of gravity is physically demanding. Every movement feels heavier, every breath requires more effort, as their bodies readjust to an environment they have been away from. Despite the discomfort, this phase is carefully controlled. The spacecraft follows a precise trajectory, designed to manage heat and stress while guiding it toward the designated landing zone. As the capsule slows further, parachutes deploy in sequence, first small drogue chutes to stabilize the vehicle, followed by larger main parachutes that dramatically reduce its speed. The violent rush of re-entry gives way to a controlled descent, the ocean below coming into view as the final destination approaches. After traveling hundreds of thousands of kilometers through space, the journey ends not with a landing on solid ground, but with a splashdown in the Pacific Ocean. Recovery teams are already in position, tracking the capsule's descent and moving in quickly once it touches the water. Within a short time, the astronauts are safely retrieved, marking the successful completion of a mission that represents far more than a simple trip around the moon. Artemis II is a proof of capability, a demonstration that humans can once again travel into deep space and return safely. It lays the foundation for everything that comes next, from future lunar landings to the long-term goal of sending humans even farther, toward Mars and beyond. And as the crew steps out of the capsule, returning to Earth after their journey, they bring back more than data and images. They bring back something intangible but essential, a renewed understanding that exploration is not a thing of the past, but a path that is still unfolding. Artemis II is not the end of a story, and it is not simply a return to where we have been before. It is the beginning of what comes next.